Good day to all of you. We are going to continue the last topic in the vector value function, which is directional derivative. I'm Tay from FKEE UTHM, Universiti Hussein, Malaysia. Directional derivative. As we know, the slope of the surface z equal to fxy in x direction and y direction are given by partial derivative fx and fy respectively. This one is for example, we have a surface like this, a paraboloid surface, and then the slope, which is parallel, the slope here parallel with the x-axis is actually given by fx, and the slope which is parallel to the y-axis is given by fy. And here, to determine the slope of surface z equal to fxy at a point p x0 y0 in the direction given by a unit vector. Let's say here, this unit vector u, which is u1i plus u2j, where this is a unit vector making an angle theta with positive x-axis, this is y-axis, and since u is a unit vector, the opposite length here will be magnitude of u, which is 1 unit sin theta, which is equal to sin theta. The adjacent length here will be the magnitude of u cos theta, and then sin u is a unit vector which is 1 unit, so this is equal to cos theta. That's why the u1 is here, this is u1, this is u2. So u1 is equal to cos theta I. U1 is cos theta, so cos theta I plus U2 is actually sin theta, so sin theta j. So using this unit vector, we can define a new type of derivative called directional derivative, which is the slope of of the surface at the point p x0 y0 in the direction given by unit vector, which is called directional derivative. Which is given du. This is directional derivative of the function fxy in the direction of unit vector is given by is actually you have the fxi plus fyj dot with the unit vector u1i plus u2j. Dot product, the result is scalar. That's why you have the component I you multiply with I, and then I dot I is 1, j dot j, which is equal to 1. That's why the result of the scalar, dot product, you have fx dot multiplied with u1 plus fy multiplied with u2. But the unit vector u is actually u1i plus u2j, or cos theta I plus sin theta j. So when at the point x0 y0, we just substitute the variable x and y by x0 y0. So your directional derivative at the point x0 y0 will be equal to fx x0 y0 multiply u1 plus fy x0 y0 multiplied with u2. So mean directional derivative is actually the slope of the surface fxy in the direction of unit vector, unit vector u at the point x0 y0. For example 1, find the directional derivative of fxy equal to 1 plus xy power 3 over 2 at the point 3, 1 in the direction of unit vector u, which is 1 over sec 2i plus 1 over sec 2j. So first of all, you know the directional derivative del u f 3, 1 will be the vector f x at the point 3, 1, fx 3, 1 I plus fy31j. So dot with unit vector. Okay, unit vector is that is given in the question 1 over sec2i plus 1 over sec2j. So this is directional derivative. First step you need to find the fx. Second step f1 and then plug in at the point 31. Then lastly find the dot product. So that is the result. So first of all we find the fx. Fx is actually with del x, the function of f given, which is 1 plus xy power 3 over 2. So we have 3 over 2, 1 plus xy, Okay, differentiations, the power will be decreased by 1, so become half. And then we need to del x 1 plus xy. That's why we will get 3 over 2. Okay, del x1 is 0, del xy we have y. So you get 3 over 2 y 1 plus xy power half. Okay, and then similarly we can find the fy. We find the fx at the point 31. Fx at the point 31 will be 3 over 2. Replace y by 1. And then x is 3, y is 1. So 3 times 1 is 3 power half. Okay, so we have 3 over 2. Okay, this is 4 power half, which is 2. So that's why fx31 we get the answer is 3. Then similarly we find the fy. Okay, fy, you just replace the delta x here by delta y. So delta y 1 plus xy power 3 over 2. So you have 3 over 2. Okay, 1 plus xy 3 power 3 over 2 minus 1 become half. And then we delta y 1 plus xy. When delta y1 is 0, delta y xy we have x. So 1 plus xy power half. Okay, and then we find fy at the point 31. So replace x by 3. So 3. Y by 1. So here we have 1 plus 3 power half. So total we have 9 over 2. Okay, this is 4 square root, which is 2. So the answer is 9. Okay, we have here. This will be first step, find fx. Second step, find fx at the point 31. The third step, find fy. The fourth step, find fy at the point 31. Okay, fifth step, so the directional derivative at the point 31. So which is denoted as duf. 31 will be the this is a fx3y and component I. So mean you have 3i, fx3y is 3, so 3i, fy31 is 9, so 3, 9. So mean this is 3i plus 9j dot with unit vector, which is given 1 over sec2i, 1 over sec2i, 1 over sec2j. Okay, the dot product, you take 3 times sec2, 3 over sec2, I dot I is 1, so plus 9 multiply 1 over sec2, which is 9 over sec2. So total we have 12 over sec2. Okay, or we find sec2, we divide sec2. So it will be 6 over sec2. Sec2 is 2, simplify with 12, which is 6 over sec2. So the directional derivative of fxy equal to 1 plus xy power 3 over 2 at the point 31 we obtain is 6 sec2. Okay, and then example, it finds the directional derivative of fxy equal to 4x cubed y2 at 2, 1 in the direction of a vector a equal to 4I minus 3j. Okay. Compare example 2 and 1. This is not unit normal vector. Hence, from a you have to make it become a unit vector. So question example 2, you have additional method, additional step where the u will be the vector a divided by magnitude vector a. Once you have the 4I negative 3j magnitude, which is squared each component. So 4 squared plus 3 squared, we have exactly 4I minus 3j divided by 5. So example 2, we have need additional one method to find the unit normal vector. And then the directional derivative at the point 2, 1, it will be the fx at the point 2, 1 at component I with fx 2, 1 I plus fy 2, 1 j dot with the unit vector. Okay, unit vector now we obtain is 4 over 5. Okay, dot with negative 3 over 5 j. Okay, so this is first step. Okay, second step, it again finds the fx. Okay, fx differentiate respect to x while y is constant. So you have 3 times 4, 12 x squared y squared. And then fx at the point 2, 1. So replace x by 2. So you have 12 times 2 squared, y is 1 squared. So 4 times 12, 48 times 1, which is 48. Okay, and then you find the third, number 4, find fy. Okay, fy differentiate respect to y while for x cubed is constant, so it's got to have 8x cubed y. And then number 5, your fy at the point 2, 1. So x is 2, 2 cubed is 8, 8, 8, 64, 64 times 1, which is 64. Because 2 cubed is 8, 8 times 8 is 64, y is 1, so 64. Okay, hence fifth, this is number 6 here, directional derivative at the point 2, 1 will be fx 2, 1, which is 48. We have 48i plus fy 2, 1, which is 64, so plus 64j dot with the unit vector, which is from a, you have the vector a divided by magnitude of vector a, which is 5. So we get 4 over 5 I negative 3 over 5 j. And then, so you have 48 times 4 over 5 minus 64 times 3 over 5. 198 divided by 5 we get the answer is 192 minus 192 over 5. The answer that we obtain is 0. Okay, directional derivative of the function fxy 4x cubed y2 at the point 2, 1, in this case we obtain is exactly 0. It means compared to example 2, example 1 is the question is directly given the unit vector. This question is given vector a, so you have to convert it to unit vector, mean vector a divided by magnitude vector a. And then directional derivative at the point 2, 1 will be the fx at the point 2, 1 I plus fy at the point 2, 1 j dot with unit vector. So doing the dot product, component I times I, then I dot I is 1, then plus component j times j, and then j dot j is 1. So we get the answer is 0. The third example now. Okay, find the directional derivative of fxy equal to square root xy at 1, 4 in the direction of unit vector u that makes an angle of pi over 3 with the positive x-axis. Okay, this one, which example 1 give unit vector directly, example 2 give vector A. Now it says unit vector u, this is unit vector u, making an angle pi over 3 with x-axis. So you know that u is actually component I will be u cos. So you have component, because u is 1, so component I will be cos pi over 3 pi. Component j is sin pi over 3j. Okay, and then next is knows that pi over 6, sin pi over 6, sin 30 degree is half. Sin 30 degree of pi over 6 is half. Sin of pi over 6 is over 6, okay, divided by hypotenuse, half here, using Pythagoras theorem. The adjacent length will get 3. And then this is 90 degree, cons here will be pi over 3. Okay, so cos pi over 3, 1 over 2. Okay, cos pi over 3 you get 1 over 2 I. Sin pi over 3 over 6 divided by hypotenuse will be 3 over 2. So here, this question, they give you an angle pi over 3. So the component I will be cos pi over 3, component j plus sin pi over 3j. So this is one more additional step compared to example 2. Okay, and then now, this is first step finding the u, second step finding the fx. So fx, we del x, xy power half. Square root is power half, so we have half, and then xy power negative half, and then del x, xy, where the y is constant. So del x, xy, we have y. So we have y over 2. Okay, power half is actually become, bring down, it become square root xy at the denominator. Okay, and then, so fx at the point 1, 4. 1, 2, this is the third step. Fx at the point 1, 4. Okay, y is 4. X is 1. So 1 times 4 is 4. Square root 4 is 2. 2 times 2 is 4. 4. Okay, so cancel there. 1. The fourth step, okay, fy. So fy is just replace the delta x here by delta y. Delta y xy power half. So you have half. Xy power half minus 1 become minus half. And then you delta y xy where the x is constant. So delta xy we have x over 2. Power half bring down become this is square root xy. So the fifth here. So fy at the point 1, 4. X is 4. Okay. this is 4, okay, 4, sorry, x is 1. Okay, x is 1, x times y, then you have square root 4, which is 2, so you get this is 1 over 4. Okay, and then the sixth step, the directional derivative du at the point 1, 4, okay, will be the fx at the point 1, 4 at component I plus the fy at the point 1, 4 j dot with the unit vector, in this case, which is 1 over 2 I plus 3 over 2 j. Okay, then plug in the fx 1, 4, which is 1. Okay, fy 1, 4, which is 1 over 4. Okay, dot give half I 3 over 2 j. Okay, so 1 product. Okay, 1 times half, you have half. Okay, and then 1 over 4 times 3 over 2, so you get 3 over 8. So the answer, okay, that we obtain is half plus 3 over 8. So example 3 compared to example 2 is here, it's not given the vector A but given unit vector u making angle of pi over 3 with positive x-axis. So component I is cos pi over 3, which is half, sin pi over 3, which is 3 over 2. Okay, and then you find fx, evaluate fx at the point 1, 4. Find fy, evaluate fy at the point 1, 4. So the directional derivative fu 1, 4 will be the fx 1, 4 I plus fy 1, 4 j dot with half I plus 3 over 2 j. So the dot product, the result is scalar, means component I times I plus component j times j. So the answer is half plus 3 over 8. Okay, and then we have a, okay, what is a definition of gradient of function of two variables? Okay, let the z is a function of fxy. Okay, let z equal the function fxy be a function of x and y such that fx and fy exist. Then the gradient of f denoted by, okay, this is del, this symbol is del, or not del, nabla. Okay, nabla, okay, fxy is the vector. Okay, inverted triangle here is called as nabla. fxy equal to fx xyi plus fy xyj. Okay, just now when we find directional derivative, we use the fx xyi plus fy xyj. This vector is actually called as gradient vector. So that's why alternative form of directional derivative du fxy is actually the gradient vector dot with unit vector, where the gradient vector is actually fx xyi plus fy xyj. Okay, and then example 4. Okay, example 4. Using the gradient vector fxy or inverted triangle to find the directional derivative of fxy equal to 3x squared minus 2y squared at the point negative 3, 4, 0 in the direction from p negative 3, 4, 0 to q 0, 1. So question example 1, unit vector is given directly. Example 2 given in vector A. Example 3 is given unit vector making an angle pi over 3. Example 4 here given 2 points. So given 2 points, we can find the vector PQ and then make it become unit vector. 3. Okay, you can have vector PQ, Okay, taking the ending point, deduct the initial point, starting point. So 0 minus 3 over 4. 0 minus negative 3 over 4. This is at component I. And then 1 minus 0. This is at component J. That's why we have is 3 over 4I, okay, plus 1J. Okay, and it finds the magnitude of vector PQ. Magnitude, we have the square root. So square each component. So you have 9 over 16 plus 1. So okay, so we have 25 over 16, which is I over 4. So the magnitude that we obtain is actually 5 over 4. Hence, first step, find the PQ and then magnitude PQ. Okay, third step, then we can find the unit vector U is actually vector PQ divided by magnitude vector PQ. In this one, given 2 points, you can make it become vector PQ and then magnitude PQ, and then you can find the unit vector, okay, which is 3 over 4I plus 1J divided by each magnitude, which is 5 over 4. Okay, so we have 3 over 5. Okay, and then this one component J, 3 over 4I divided 5 over 4, 4 and 4 cancel, 3 over 5I. So component J, 1 divided by 5 over 4, so become 4 over 5J. So this is a, okay, this is a unit normal vector. 3x squared minus 2y squared. Third step, fourth step, okay. And then we have the fxy is 3x squared minus 2y squared. We find fx. So we have 6x. Okay. And then fx at the point negative 3, 4, 0. Negative 3, 4, y is 0. So I got 6 times negative 3 over 4. So negative, we simplify it. So negative 9 over 2. Okay, and this is the fifth step. Number 6, we find 4 is, okay, 5 fx. Number 5 fx at the point negative 3, 4, 0. And the 6th step, find the fy. Delta y 3x squared 0. Delta y negative 2y squared, get negative 4y. And then fy x at the point x negative 3, 4. Y is 0, so answer is 0. Okay, so number 7, the gradient vector delta f xy okay. Gradient vector at the point negative 3, 4, 0. Negative 9 over 2I 0J. So number 8, the directional derivative del du f negative 3, 4, 0 will be the gradient vector delta f at the point negative 3, 4, 0. This is found dot with unit vector, and here we get negative 9 over 2 0. Unit vector that we obtain is 3 over 5 I plus 4 over 5 j. 3 over 5 I plus 4 over 5 j. So I have negative 9 over 2 multiplied 3 over 5. Component j because 0 times 4 over 5 is 0. Okay, so you get negative 27 over 10. It means using the gradient vector del k del this is nabla fxy, you can find the directional derivative. It's actually your du f xy is a del nabla or gradient vector delta del f nabla gradient vector dot with u. And then the directional derivative that we want to find is at the point x is negative 3, 4, y is 0. So you have the gradient vector at the point negative 3, 4, 0. The dot with the unit vector that we obtain is 3 over 5, 4 over 5. Okay, where the gradient vector is actually gradient vector, so it's a vector. It's a fx, I, fy, j. So this question is given the PQ. So you have to find vector P to Q takes a ending point, deduct the starting point. So x1 deduct x0, so in the component I, y1 deduct y0 is at the component j, and then you find magnitude PQ. Once you can find the unit normal vector, which is vector PQ divided by magnitude of PQ. Then, as usual, you find from f, we find fx, then fx at the point negative 3, 4, 0, and we find fy at the point negative 3, 4, 0. So the gradient vector at the point negative 3, 4, 0 is actually the fx at the point negative 3, 4, 0, which is negative 9 over 2. At component I, and then fy negative 3, 4, 0 at the component j. Hence the directional derivative du f negative 3, 4, 0 is a gradient vector. Okay, gradient vector at the point negative 3, 4, 0 dot with q. We have this answer. Okay, and here we can have the properties of the gradient. Okay, let f be differentiable at the point x1. We can find the fx, fy. Okay, if the gradient vector equal to 0, then the directional derivative will be equal to 0. Because if here 0 dot with any unit vector, we get 0. And the direction of maximum increase of f, direction. So we want where's the direction. Okay, and the direction is given by direction of the gradient vector. Okay, if the direction of maximum decrease will be negative of gradient vector. Because gradient vector, we have the direction and the magnitude. Okay, the magnitude of the gradient vector is actually maximum value of the directional derivative. Okay, if we have a negative magnitude of gradient vector, it's actually the minimum value of the directional derivative. Or we call maximum rate of decrease is the maximum rate of increase. Okay, prove that 2 to 5, we know the directional derivative du fxy is actually the gradient vector dot with q. Okay, and using the dot product, we have the magnitude of gradient vector multiply magnitude of q cos theta. U is 1, that's why we have the magnitude of gradient vector multiply cos theta. Okay, cos 0 is 1. Okay, so means when theta 0, okay, the cos value is from 0 to 1. So okay, when maximum is 1, okay, cos theta will give you value 0 up to 1. So the maximum value happen at 1, okay, 1 when theta is 0. It means cos 0 you get 1, cos pi you have cos theta the value negative 1 to 1. Cos value of negative 1 to 1. Cos 0 is 1, cos pi is negative 1. That's why, okay, means the directional derivative, they have the value from minimum is negative magnitude of delta, okay, magnitude of the gradient vector. Maximum is 1 of the 1 time the magnitude of gradient vector. That's why in the maximum value is a magnitude of gradient vector. Minimum value is negative of the gradient vector. Okay, and this happens if maximum is actually when theta equal to 0 because cos 0 is 1. Minimum happens when theta equal to 1. Because initially they have this one is Q and this is a theta. The theta 0. They give the maximum directional derivative. And theta 0 give the maximum directional derivative where the magnitude is given by magnitude of the gradient vector. Okay, and then at here, this is theta equal to pi. Theta equal to pi will give the minimum of directional derivative where the magnitude is actually negative of gradient vector. And the direction, if they ask at which direction the function fxy will increase the most, okay, and will be at the direction of gradient vector. Okay, in which direction the function fxy will decrease, okay, the most will be at the negative of the gradient vector. Okay, example 5. So in what direction is a function fxy equal to x, exponent 2y minus x increase most rapidly at the point 2, 1? And what is the maximum rate of increase? Okay, in what direction is f decreasing most rapidly? Okay. Let's see. Okay, one direction increasing most and the maximum rate of increase, direction decreasing most. Okay, direction increase most is actually the direction increase the most rapidly is given by the direction of gradient vector. Okay, and they want at the point 2, 1. Okay, this is number 1. Number 2, maximum rate of increase. Maximum rate of increase, okay, is actually magnitude of the gradient vector, the nabla f 2, 1. Okay. The third that they want, directions decreasing most rapidly, okay, is given by negative of gradient vector. So direction increase most rapidly is given by gradient vector. If decrease direction is negative. So if they want the minimum rate, let's say if they want minimum rate decrease. Is actually given by negative of the gradient vector at the point 2, 1. Okay, so the x 2y minus x. Xy is x exponent 2y minus x. X times exponent 2y minus x. So we find the fx. Okay, we have product A, we have to, for fx we have x, then this is a function of x, so we have to use the product rule. Then you delta x uv will be your u v prime plus v u prime. So u is x, and then we delta x exponent 2y minus x, then plus the v exponent 2y minus x, and then u delta x x. This is u, this is v, this is v, this is u. Okay. So delta x exponent 2y minus x is negative exponent 2y minus x. Delta x x 1, so it's plus exponent 2y minus x. Okay, so you can factor out exponent 2y minus x 1 minus x. Okay, this is a fx. And then we have the number 2, the fx at each point, at the point 2, 1. Okay, fx at the point 2, 1. 2, 1. So y is 1, x is, so y is 1, x is 2. X is 2, evaluate. So x 2 minus 2 exponent 0, which is 1. So 1 minus 2 is negative 1. So the answer is negative 1. Negative 1. Okay. And then number 3, find the fy. Okay, fy no need to use product rule because this when fy x constant. So you have x is constant, and then you just delta y exponent 2y minus x. Okay, so we have 2x exponent 2y minus x. So evaluate fy at the point 2, 1. Okay, plug in x is 2, y is 1. So you have 4, okay, because exponent 0 is 1. Okay, so now your gradient vector at the point, so del plug f 2, 1. It's actually you have negative 1i plus 4j. Okay, and then unit vector that we obtained just now is what? Oh, never mind the unit vector. Okay, we just want direction increase most rapidly. Okay. So the direction increase the most rapidly will be given by the gradient vector, which is negative 1i plus 4j. So the answer for here, okay, direction increase most rapidly, okay, is given by gradient vector at the point 2, 1, 2, 1, which is negative 1, 4. So in this one, the answer is negative 1i 4j. Okay, if the directions decrease, the most rapidly. You have negative of this, negative of the gradient vector. So you have a 1 I plus 4j. Okay, and then the maximum rate of increase, maximum rate of increase is actually magnitude of here. Okay, so that's why this one, the magnitude of this, so negative 1 you square it, plus 4 you square it, the answer is 17. The minimum rate of decrease is negative of this, will be negative 17. Okay, the negative 17 and in the direction I plus 4j. And then this is the direction increase most rapidly is given at the direction negative I plus 4j, and the value increase the most rapidly is actually 17. Okay, we go back to here. From the property of the gradient, okay, the direction of maximum increase of f is given by gradient vector. So direction of minimum increase is negative of gradient vector. You want the value, so it takes the magnitude of your gradient vector. So there is a maximum value. Minimum value is negative of magnitude of the gradient vector. Okay, that's why in this equation we have the function fxy equal to x exponent 2y minus x. So you find the gradient vector. The gradient vector is actually gradient vector is given by gradient vector is fxy is actually your fx xy at the component I plus the fy xy at the component j, and then x is 2, y is 1, so this is already evaluated, which is negative 1i, then fy21 is 4, so it's a 4j. Means the gradient vector will tell you the direction where the function increased the most, and the value is given by magnitude of the gradient vector. Okay, if the direction in which the function decreased the most is given by negative of gradient vector, and the value of the function decreased the most is actually negative of the magnitude of the gradient vector. Okay. And then example 6. Let the fxy equal to x squared exponent 1. Find the maximum value of the directional derivative at negative 2, 0 and a unit vector which gives the maximum increase. Okay, this one compared to just now is only we want a vector give the most maximum increase, means is a gradient vector, and then we want unit vector, so mean from gradient vector you divide by magnitude of the gradient vector. Okay, so first of all, okay, I think before you find the fx, you have 2x exponent 1. Second step, find the fx at the point negative 2, 0. So negative 4. Right, substitute x negative 2. Exponent 0 is 1. Okay, the third step, you find the fy. Okay, fy, x squared is constant, that's why I have x squared exponent y. Okay, and then you find the fy at the point negative 2, 0. So you have 4. Okay, and then we can find the gradient vector. There are nukla f negative 2, 0, which is fx negative 2, 0, which is negative 4i, and then fy negative 2, 0, which is 4j. Here, gradient vector nukla f xy is actually, you have the fxi, fyj. Okay. So now, maximum value of the directional derivative. Number 6. So maximum value of the directional derivative at the point negative 2, 0 is actually magnitude of gradient vector at the point negative 2, 0. So magnitude of a gradient vector. So each negative 4 is squared. So 4 is squared. So it's cert 32. Okay, cert 32 or 16 times 2. Cert 16 is 4. So you have 4 cert 2. Okay, so this is the maximum value of the directional derivative. Okay, and unit vector which give the maximum increase. Okay, vector is actually gradient vector. So you want if you want unit vector q, then takes a gradient vector at the point negative 2, 0 divided by magnitude of the gradient vector. Okay. So which is negative 4. Gradient vector is obtained in step 4, which is divided by 4 cert 2. Okay, so you can have cert is negative 1i, 1j divided by cert 2. So this question, example 6 compared to example 5 is only find the direction which give maximum increase. So the direction is given by gradient vector, but they want unit vector. So unit vector will be the gradient vector divided by magnitude. Magnitude is actually maximum value of your direction derivative they obtain is step 6. So that's why the unit vector they obtain is negative I plus 4j divided by cert 2. So we find it's actually a directional derivative. Can conclude back directional derivative du f x y is actually, you can initially we use this notation fxi plus fyj dot with the unit vector. Okay, where the fxi plus fyj is actually your gradient vector. Okay, initially example 1, 2, 3, I think 1, 2, 3 we use the fxi directional derivative at fxi plus fyj dot with unit vector. And example 1, we directly give you the unit vector. Example 2, we give a vector A. So to make u become unit vector, you give vector A divided by magnitude. The third example, you making an angle pi over 3 with the unit with the x-axis. So u is will be the u will be for that. Example 3, the u making an angle pi over 3. So the component I is cos pi over 3, pi over 3 with positive x-axis. Component j is sin pi over 3. So example 1, 2, 3, we use a directional derivative is actually fxi plus fyj dot unit vector. And the unit vector can be either they give it directly or they give a vector a. So you a divided by magnitude a become unit vector, or they make it a certain angle with positive x-axis. Okay, and later on we use we actually use the gradient vector. So mean directional derivative will become the gradient vector. Okay, and this one is used give you PQ. So from PQ you can find the vector PQ and then magnitude vector PQ. So you can make it become unit vector. Okay, and from the gradient vector that we introduce, gradient vector is actually fxi plus fyj that we introduce. We can have the property, we can get the direction where the functions fxy increase the most maximum is given by gradient vector, and the value is actually magnitude of the gradient vector. If decrease the most rapidly, the direction is given by negative of your gradient vector, and its value that decrease the most rapidly will be given by look at this one, this property. Okay, this is important. Direction of gradient vector give you the direction where the function increase the most rapidly, or they call steepest ascent. Its value is a magnitude of your gradient vector. Direction decrease the most rapidly. Direction of steepest descent is a negative of gradient vector. Its value is negative of the gradient vector. If the last example, they want the unit vector, then you take the gradient vector divided by magnitude of gradient vector. Okay, with this, thank you for your attention.